Mic test 1, 2, 3. Good day, everybody. Yeah, this is Alex Chu, speaker support from IDEC in Zuni Asia. Thank you for taking your time today to attend today's webinar, which will talk about how IDEC new Category 2 safety relay help to save money as well as keep operators safe. So this will be the content today. We will see what is safety relay and why safety relay is needed. So while talking about safety relay, we will come across a few terms like safety categories as well as performance level, which we will see what are these two terms as well. And finally, we will see how our IDEC Category 2 safety relay can help to save cost and operator. So what is safety relay? So you guys can understand a safety relay like a normal relay, but with a special logic inbuilt, which constantly check the signal from its input device as well as output device, constantly receiving this signal and check. So whenever the logic it detects there is any unsafe situation or they detect any abnormal situation, it will deactivate the output contact, okay, which drive the power supply to machines or robot directly. So if let's say the diagnostic system notice there is any unsafe situation, it is going to cut off the activated output, which directly cut off the power supply to robots and machine. So this is how safety relay works. So why a safety relay is needed? So imagine you have two machines. One you put inside a safety fence, okay, and you monitor the movable gate of this safety fence by using safety interlock switch, okay, which the send signal is sent to a safety contactor. And you also have another robot which you use an emergency stop button with the signal going to a safety contactor that is directly controlling the power of this robot or machine. So imagine you have this setup. It will work exactly, okay? If let's say during emergency situation, you open a gate, okay, you want to enter this dangerous zone. Okay, the signal from the safety interlock switch will not be sent to this contactor, and it will immediately cut off the machine power, okay? Similar to this case, during emergency situation, you press the button, okay? The signal going to safety contactor will be cut off and hence will stop the machine as well. So this will work perfectly during normal situation. Okay? But you imagine, since there is no safety relay being used in between the safety device and the output safety device, you imagine if let's say there is any welding happening inside the NC contact of this safety interlock switch or the NC contact inside this emergency stop button. So during this situation, even you open the gate, even you press the button, the machine will not stop because the NC contact is not broken away, which means the signal will continuously given to this contactor and the robot will continue to run. The machine will continue to run. So this put the operator in a dangerous situation, okay? So this is why a safety relay is needed, because by inserting a safety relay in between the input safety device as well as the output safety device, it will provide a diagnostic. Because the feature, the construction of this safety relay is it has a logic which constantly taking the signal from the safety device, the safety interlock switch or emergency stop button, constantly doing the monitoring for this signal from the input device as well as the signal feedback from the output device. Whenever there is any welding contact abnormalities found on the input device or output device, it will not allow the next startup, okay? So the main reason for this safety relay to be present in the control system is to construct self-monitoring and a safer control circuit to control the machines and robot, okay? Other than that, most of the safety relay, it requires a manual start command, okay? Which means that before an operator can start a machine or robot, an additional step is required by operator to check the surrounding area, okay, the area surrounding the machines or robot, to ensure it is safe and nobody is nearby this dangerous zone before he can send a command to this to start this safety relay and start the robots. Okay, so this additional step ensure a higher safety level of the whole control system. So this is the reason why safety relay is recommended in a safety control system. Okay, our title today is mentioned category 2 of safety relay. So you guys might be interested to know what is safety category. Safety category, by definition, you can understand it like safety control architecture, or in other words, it could be the arrangement, okay, or interaction between components inside safety control circuit, okay, as defined in ISO 13849-1 in year 1999, which this ISO standard is talking about the safety of machinery, okay, which is mainly the interaction or the architecture, the component inside this safety control circuit, right? So safety categories, it is divided into 5, B, 1, 2, 3, 4, okay, with B being the lowest category, 4 the highest category. So from low category to high category, the resistance to fault is increasing, which means that for higher category, it will tend to have better resistance to fault. Fault means whenever there is any failure happening inside the circuit, okay, higher category will tend to handle it better, okay, during any fault situation. Okay. Due to the structural arrangement of parts in higher safety category as well, they have the capability to handle it without losing the safety function for the whole control system. For example, in the safety control circuit, you might have 5 components. If let's say one of the component is facing a failure, for higher category, if you arrange the circuit, you design a circuit according to the higher category, okay, it will be able to manage this fault, and it will not lead to lose the safety function for this control circuit, which means that it will still be able to protect the operator. So which means indirectly it means for higher safety categories will have better reliability. Okay, so this is safety category in general. Let us take a look in detail for each category. So let us start with category B and 1. Okay, B and 1 being the lowest category, okay, among the rest. You can see that the architecture is pretty simple. It is a single channel architecture. It consists of input device, logic device, and output device. So, or probably we can call them as a safety related part of control system. So which means that they are a component that in a control system that is responsible for the safety, okay, of the whole circuit. So this is the architecture of category B and 1. You can see that there is no monitoring between devices to devices. Okay. So example of circuit look like this. Let us talk about category B first. For category B, the most basic one, there is no requirement for the design and also the material of the component to be used. For example, in category B, there's no requirement saying that you must use an e-stop button to protect your circuit. So any buttons with any NC contact and any contactor can be used, okay, in category B. Whereas for category 1, there is a slight improvement. Okay, for category 1, it is recommended to use a component with well-tested material or component with well-proven design according to certain IEC standard or according to certain safety standard. Okay, for example, in these two cases, the interlock switch is being used, and the NC contact of this interlock switch and the NC contact of this emergency stop button, both of them are direct opening action type. You see this logo, right? So this direct opening action type means it comes with a special design. So whenever the actuator is pulled out from the interlock switch, or whenever this button is pressed, the design of the NC contact will ensure it will open the circuit to ensure no signal going to the contactor, and it will stop the power supply of the machine. So other than these input devices, the output devices also need to be fulfilling certain must be well according to well-proven design, okay, or well-proven material. Okay, for example, not normal contactor can be used, but safety contactor should be used for category 1. Okay, so in terms of the relationship between input devices and output devices for category B and 1 is pretty straightforward. Okay, so you see there is no complicated logic in between. The relationship is simply an AND logic. So whenever this one is off, then what we have to do this one. There is no additional logic. So this is category B and category 1. Let us see the category 2, which is our new safety relay, which is using this category. Okay, you can see that the architecture consists of 2 channels, function channel as well as test channel. It's quite different compared to category B and category 1. So other than this, you can see there is a monitoring, okay, between device to device in this category 2. Not only that, inside this logic device, there is a test equipment as well, which constantly testing the signal from logic device, input device, as well as output device. Whenever the test equipment notice there is any abnormality or unsafe signal, we will send out a signal, okay? This is the output from the test equipment. So this is the architecture for category 2, okay? So in terms of circuit example, you can see it's pretty different from the previous. Whatever improvement have already done in category 1 should be used here, okay, which is the input devices and also the output device. They should use material, well-proven material, and also design with well-proven, according to well-proven standard, okay? So this is for sure. And another thing you can notice here, the signal from the output device is feedback to the logic device, okay? A1, it's feedback to the logic device, okay? So that the test equipment and also the logic device can constantly monitor the signal from input device as well as output device. Whenever there is any abnormalities, it will send an output. The user can either use the output to notify a PLC or link it to an indicator light to inform there is some problem in this safety function. Okay, so this is category 2. So level up category 3. So for category 3, you can see the architecture is again different. So for this time around, the architecture comes with 2 channels, okay, with redundancy also. You can see that there are 2 input devices, 2 logic devices, as well as 2 output devices. And there is monitoring between logic device and output device, as well as there is cross monitoring between channel to channel. Okay, so it offers better diagnostic and monitoring in category 3. Let us take a look at the circuit example. So as you can see here, of course, whatever thing implemented in the previous category 1 need to be used, okay, well-proven component. And since redundancy must be used over here, 2 NC contact, okay, need to be used to feed 2 different signals to the logic device. At the same time, 2 output device must be used, K1 and K2. Put them in series to control the power supply to machines on robot. Okay, and the signal from these 2 output devices must be feedback, okay, to the logic device so that the logic device can constantly monitor all this signal. Okay, whenever similar thing, whenever it detects any abnormalities, it will cut off the output controlling circuit to stop the machines and robot. Okay, so this is how category 3 works. So let us take a look at the last category, which is the highest category. You notice that the architecture-wise is not so much different compared to category 3. Okay, so category 4. The only difference between category 3 and category 4 is you can see just now it was dotted line for the monitoring and cross monitoring, whereas for category 4 it is a solid line, which means that the monitoring between device and the cross monitoring between channel is implemented in a more diversified and also a more frequent way, more powerful diagnostic. Okay, so this is for category 4, which is able to offer the best diagnostic and also monitoring between devices and devices. Okay? In terms of circuit wise, it's not much different compared to category 3 because everything is happening inside the logic circuit, logic device. Okay, so this is categories. Performance level. This is also another term that you will always come across, especially when you go through the catalog or data sheet of any safety devices. For example, safety relay, safety light curtain. Normally you will come across this performance level, this term also. Okay, so what is performance level? Let us take a look. So you can understand the performance levels as an average probability, okay, of dangerous failure to happen in 1 hour. So in other words, is the chances for a dangerous failure to happen in 1 hour. Okay. Dangerous failure, you can understand it like a failure. If let's say you have a safety control system, okay, any of the fault happening inside this system which lead to the loss of safety function, okay, which means that if let's say this fault happen, the control system will no longer be safe to the operator. So this is what it means. So the chances for this fault to happen in 1 hour. Okay. So performance level wise is divided into 5 levels, with A being the lowest level, E is the highest level. Okay. For performance level A, which is the lowest level, will tends to have the highest probability, okay, for this kind of dangerous failure to happen in 1 hour. Our performance level E, which is the safest performance level, will have the least chance, okay, lowest average probability for the dangerous failure to happen. Okay, so why is this performance level, this term is introduced? Okay, before year 2006, everybody is comfortable to use category or the architecture, how the components interact with each other. Everybody is comfortable to use this category to evaluate how safe is your control system. Okay, but there is a revision in 2006. Why this revision is needed? Because people start to notice when getting more and more safety devices being used in the control system, especially those involve electronics. Okay, by using categories to evaluate the safety level is no longer sufficient. Okay, so that's why there are a few elements need to come in together to evaluate the safety level. Okay, probably we call it performance level of this control system. So the first new term coming in is the mean time to dangerous failure. Later we'll take a look in detail what is this, but in simple words, mean time to dangerous failure is the mean time in number of hours. Again, is the number of hours for dangerous failure to happen. Okay, the symbol is MTTFD. The second term is diagnostic coverage, which means how good this safety device that contains electronic, how good it is able to diagnose the fault happening inside the control system. Okay, so the third term is common cause failure, which is an evaluation to see that whether a failure happening inside one of the device is due to external factors or probably due to the failure of another device. Okay, so all these terms, okay, it comes to the new term called performance level that we have just seen. Okay, when we evaluate the performance level of the safety control system, all these elements need to come into place. All right. So just now we have already seen category in detail. Let us take a look what are all these terms. Okay, one by one. Start with mean time to dangerous failure first. Okay. So you can understand this MTTFD as the mean time in number of years for a dangerous failure to happen. Okay. Which the dangerous failure is definition of this dangerous failure again is the same as what I mentioned just now. Imagine you have a few devices in the control system. The dangerous failure means whatever fault, whatever failure that happened inside this control system that will lead to the failure, will lead to the loss of the safety function. Okay, which means that in case of any fault happen, okay, your control system, your safety control system might no longer be safe for your operator. Okay, so according to calculation and study, this kind of dangerous failure is less likely to happen in redundant system. Okay? For example, category 3 and category 4 architecture is less likely to happen. So it makes sense because if you imagine you have a single channel architecture, only consists of input device, logic device, and output device. Any of the small failure happen on any of the device will lead to the loss of the safety function. Whereas if you have a redundant system, okay, even though you have a fault happen on, let's say, output device O2, but you still have another channel which is able to maintain the safety function. So even though right now my operator press the emergency stop button, even though this contactor is already out, it's having problem, but this channel will still be able to stop the machine and keep the operator safe. All right, so this is what it means, why the redundant system got higher or better MPTFD. So the next term is diagnostic coverage. Okay, we can understand this term as how effective, how capable of your safety control system to do a diagnostic, okay, to identify, to detect whatever dangerous failure that could happen within that system. So give you a simple example. Let's say you have a safety relay, okay? Because this safety relay is quite complicated components. There are electronic circuit boards inside, involve a lot of components like diode, transistor, and so on. So after evaluation, we noticed that there could be 10 dangerous failures that could happen within this safety relay itself. Okay, so if let's say this safety relay is able to detect all the dangerous failures that could happen in this safety relay, we say that okay, this has a very high diagnostic coverage, okay, because it's able to detect more than 99% of the failure. Okay, but if let's say it is only able to detect 8 out of 10 dangerous failure that could happen, which means only 80%, so it is rated as low diagnostic coverage. Okay, so later we'll see how all this term is affecting the performance level. Okay, so the last term, which is common cause failure. So this common cause failure is actually evaluation. So imagine when you are designing a safety control system, okay, this common cause failure is an evaluation that the designer should do to see any of the failure in the safety control system, whether it is caused by the failure of another device within safety control system, or it is caused by an external factor. For example, in this case, if let's say I have this control system, this architecture, input device number 1 and output device number 2 fail, okay, and the failure is because of an external factor, which is an overvoltage from external. So for this case, it's acceptable. But if let's say the failure of output device number 2 is because of the failure of it failed, is because of this logic device number 2 failed. So in this case, the designer will need to review the circuit because this is not acceptable, right? So actually in ISO standard 13849-1, okay, there is a questionnaire inside. So the designer for the safety control system need to go through the questionnaire. Okay, after go through all the questions, they have to ensure their design achieve at least 65%, 65 points. Okay, they only consider that the control system design is considered safe. Otherwise, they have to review the whole design and go through questionnaire again. So this is common cause failure. So after going through all the terms, let us take a look at the relationship between performance level and the rest of the elements that we have gone through just now: categories, mean time to dangerous failure, diagnostic coverage, and common cause failure. So some references, they indicate the relationship in a chart form. Okay. For example, if let's say you are right now designing a category 2 architecture system. Okay. So from this chart, you can see category 2 is over here. So immediately you can know the maximum, the performance level able to cover by this architecture is ranging from A, B, C, and D. Okay, which is again determined by the diagnostic coverage, whether its diagnostic coverage is low or diagnostic coverage is medium. Okay, which can determine, as well as the mean time to dangerous failure of each channel. Okay, if you are using devices or component with high mean time to dangerous failure, you will be able to achieve higher performance level. Okay, so this is how to integrate this chart. Some references indicate the relationship in table form. Okay, but not to worry too much, because this table is showing exactly the same thing as this chart. The only thing is in table form. All right. So come back to the example just now. If you are designing a category 2 architecture system, okay, so the performance level you are able to achieve, your system is able to achieve, is from A to D. Okay. Okay, so by varying, by using a component with different diagnostic coverage or different MTTFD, you will be able to achieve different performance level. Okay, so this is how to integrate the relationship table, or as well as the relationship chart between performance level and the rest of the affecting elements. Okay. So now, after understand performance level and its relationship with all the contribution all the contributing factors, you guys must be quite curious which performance level that your safety control system should achieve. Okay, so not to worry too much. If let's say now you are a customer, okay, and you are a supplier probably for safety relay or safety light curtain or so on, not to worry too much about that, because normally the customer who are setting up a production process with machines or robotic arm, they will provide this information to you. They will either do the evaluation or risk assessment themselves, or most of the case they will get a consultant, a safety consultant, to do the risk assessment for the plant they're going to set up, and they will provide you with the required performance level. Then from there we can suggest a suitable component or architecture for them. Okay, so how normally a consultant do this risk assessment? So let me take an example for this case. Let's say your customer is going to set up a robotic arm, which is used to do welding on some workpiece. Okay, without a safety fence, for the first case, without safety fence. Okay, so they have operator which constantly need to work around the robotic arm in order to put the workpiece here manually, and once the welding is done, then he will remove the workpiece. He constantly need to move around this area nearby the robotic arm. So for this case, normally when the consultants start to do the risk assessment for this case, they will start at this point. There are mainly 3 questions they will ask. The first question is severity of injury. So how serious it is when this robot arm come into contact with the operator which is working nearby. Whether it's a slight injury which can recover very soon, or it is a serious injury which might cause a broken bone or even death. Okay. So for our example here, I would say it is a serious injury because robot arm is moving fast. Once it get contact with the operator will be quite serious. So we will take the lower path, okay, S2 path. So the next question is the frequency and the exposure time to the hazard, okay, whether it's seldom. So how to define seldom? Seldom, it is defined as one time less than 50 minutes or less than 5% of the overall robot operating time. Okay, if more than F1 means F2, frequent. So for our example here, since the operator need to always work around this area, okay, so I would say it's frequent. So we have no choice, have to take F2 path. Okay, come down here. So the last question is possibility to avoid a hazard. Okay, P1 is possible, P2 is scarcely possible. Since this robot arm is moving very fast, okay, it's quite impossible for us to avoid if we are standing nearby, especially when we are concentrate our work in some other area. It's quite impossible. So this ends up a required performance level of E. So this required performance level E is the highest required performance level. So which means that if let's say your customer give you this required performance level E, it's actually quite a headache for the designer because it's actually quite costly and the system will be quite complicated to suggest solution or safety control system that can achieve this PLE. So in order to avoid this, it is always recommended to implement some action to reduce down the overall risk first before do the risk assessment. Okay. For our example here, the simplest action that we can do is to do a fencing surrounding this robot arm. Okay. So after do the fencing, we can do the risk assessment again, okay, by asking the same question. So let us restart again at this point. Let's see what is the difference after we have reduced down the risk through this way. Okay. So severity of injury, because robot will still be moving at the same speed. Let's say there is a chance for robot arm to come into contact with operator, the injury will still be serious, so we'll take the lower path. And the second question, this will determine the different frequency or exposure time to hazard, because this time around we are already using safety fence. So most of the time, operator will be working outside of the fence, less chance to interact with machine, this robot. So most of the time, even though there is a need, probably most of the time is during maintenance time. Okay, and the overall time will be shorter than 5% of the total operating time of this robot. So this time now we can take an F1 path. Okay, and the last question, for possibility of avoiding hazard. Okay, even during maintenance time, the operator need to work around this area. We can still, because during maintenance time, the robot speed will be adjusted to around 10 to 20% of full speed only, okay, which means the robot is moving very slow. So this time now, it is possible to avoid, okay, under these slow conditions. So we are able to go E1 path, okay, which will give us a totally different required performance level for this setup. Okay, so the required performance level will be C, which will give plenty of room for the designer to come out various solution. Okay, so this is how the required performance level of a robotic system or machine determined. Okay, so according to the formula to come up with performance level of our solution, so this is the formula. Once your customer give you the required performance level, you got to make sure the safety control system that you design must be at least equal or higher than the required performance level. So the example just now is C. So that means we can play around C, D, or E for our system. So let us put this thing, highlight this thing in the relationship table just now. Okay? You can see that for performance level C, D, and E, actually is widely covering different categories, different diagnostic coverage, as well as different mean time to dangerous failure. So which means that the designer got the flexibility to choose what kind of design or what kind of proposal in the safety control system based on the budget and cost available. So later we will take a look how our IDEC new category 2 safety relay can play a part, okay, in this example. Okay, so before we see how our safety relay can help, let me quickly go through what are the safety relay available in IDEC. Okay, so I believe you guys already aware we have our HR series, HR1S, HR2S series of high-end safety relay, okay, in our IDEC product range. Why I say high-end is because both of these series, they are able to achieve a safety categories of minimum 3, and most of them are 4. And the performance level wise, all of them is able to achieve a maximum performance level E if you use this safety relay to interact with other safety devices in the network. Okay, it's able to achieve a maximum performance level E. All right, and most of them, it comes with sufficient quantity of safety output, which can be used to control robot or machine's power supply. And most of them comes with auxiliary output as well, to feedback signal to PLC, indicator light, alarm, and so on. And we have 2 models, which even come with time delay output. Okay, so why is this time delay output is important? What is the application of this? So this is mainly used to perform control stopping. Control stopping means not an immediate stop. For machine or robot stop, we divide it into 3 stopping categories. Category 0, which is an immediate stop. Category 1 stopping, which is we allow the machine, once we press the stop button or we actuate the safety interlock switch, we allow a few seconds for the robot, especially those heavy big robot, to back to the safe position. We allow a few seconds. Okay, that is for control stopping. So we have this ATE, HR1S ATE, HR2S 332NT, which is able to achieve the control stopping. Okay, now, recently we just launched this HR5S series of safety relay from IDEC. Okay, it is a category 2 safety relay. But even though it is a safety category 2 safety relay, surprisingly or impressively, it is able to achieve performance level C and above, C and D. Okay, and not only that, we have 1 model which is able to do control stopping as well. Okay, later we'll take a look. So some of you guys might be curious how a safety category 2 safety relay able to achieve performance level C and D. So this is actually how it works. So for our safety relay, by using a good diagnostic system in the safety relay, okay, medium diagnostic, we are able to achieve a maximum D, performance level D, with the components we select, the electronic components we select. Okay, got a high mean time to dangerous failure. Okay, so it's able to achieve. So this is how we make our safety relay, the category 2 safety relay, able to achieve such a high performance levels. Okay. So now let us come back to the example just now. So in our example in the previous session, the required performance level is C, and we know that the designer got a free hand to work out the proposal, the safety control system, which is able to achieve either performance level C, D, or E. Okay, so of course the designer can use the highest category safety relay that will definitely achieve the purpose. They will definitely achieve performance level E. Okay, but if you want to help the customer to save the cost, set up cost, or he want to increase his own design benefit, okay, he is actually able to use this category 2 of safety relay while achieving the same required performance level. Okay, so as we all know, category 2 of safety relay, the cost of it is definitely lower than category 3 or category 4 of safety relay. Okay, let's show you guys how the cost of category 2 safety relay is cheaper. So normally for category 3 and 4 of safety relay, because of category 3, 4, redundant circuit is required. 2 channel, if you still remember, category 3, 4, the circuit architecture is redundant, got 2 channels. So it comes with redundant logic circuit inside. So this logic circuit is no need to have inside category 2 safety relay. Same as the redundant output circuit, which is a need, which is must in category 3 or category 4 safety relay. But again, for category 2 safety relay, this is not necessary. Some of the high-end model even come with adjustable off delay timer, okay, where a rotary switch is available on the hardware for the user to adjust the timer, like how many seconds they want. They allow the robot to stop once the emergency stop button is pressed. So when the user is able to adjust from 0 second to 30 seconds, etc. Everything is built on the hardware. But how our IDEC category 2 safety relay achieve the same purpose while lowering the cost? We actually do not make an adjustable off delay timer on top, but we create different model for different timer. For example, this HR5S T025. This is a model that comes with delay timer 250 milliseconds. Okay, and for this model T400, it comes with a 4-second delay timer. So as long as the designer is very sure how many seconds he needs for his robot to back to the safe position before a complete stop, he can cut down his cost by selecting the right timer with the correct off delay timer. Okay? So this is how we help to save the cost in terms of the category 2 safety relay. So as we all know now, category 2 architecture do not need to have redundancy. Okay, so which means that if the designer choose to go for category 2 of safety relay, the components, the safety component to interact with this safety relay, okay, for example, the e-stop button and safety switch, they do not need to have 2 NC contact. Okay, 1 NC contact is already sufficient. So from here we save some money. As well as the output device, we do not need to use 2 contactors. For the case of category 3, 4, yes, we have to use 2 contactors for redundancy. But for category 2, there is no requirement to use 2 contactors. Okay, so this further saves some cost. Okay, so as a summary, if the designer choose to go for category 2 of safety relay instead of category 4 of the safety relay, first of all, you can save some costs in terms of the safety relay itself. Secondly, category 2 doesn't require redundant component, so it is able to save additional cost here, while category 4 needs 2 safety contactor. Okay, since more components needed in category 4, so it occupied more space in the control panel, while for category 2, it will occupy less space. One thing is because of the safety relay already slim enough. Okay, second factor is the single component, which is able to contribute to 41% down in terms of size. Okay, so if less space is required, which means the control panel can be sized down. This will further save cost. Okay, if you buy a big panel and a small panel, definitely the panel will cost lesser. Okay, and for category 2 system also, since we only need to do single wiring or single component. Okay, so again, we are saving 50% of our man hour, which doing the wiring. So this is the third factor that contribute to the cost saving. Okay. After talking so much about the cost saving, let us take a look how our category 2 safety relay can help to keep operators safe. So after visiting so many customers in this region, especially like countries like Malaysia, Indonesia, India, and so on. We notice that most of the customer, yes, they do have safety device, emergency stop buttons, safety contactors, okay, but they do not use safety relay. Probably safety relay probably cost them a lot. Okay, this is normally what they do. They use the PLC that controlling the machine to control the stop as well. Whenever emergency stop button is pressed, the signal go to the PLC, which controlling the machine, and they let the output of this PLC to cut off the machine power. So in normal case, probably it works, yes, but there is a risk. If let's say during the real emergency time, due to the slow response of the PLC, or probably the PLC go hang, we are not sure. So this again, putting the operator in risk. So since now we have our new category 2 of safety relay, which don't really cost a lot. And in terms of the wiring change, it doesn't really involve a lot of wiring change as well. So if you have customer who are right now using this solution, probably it's a good chance for us to introduce this, and we can do a calculation for them how much it will cost additional in order to keep their operator safe, because we believe that the safety of the operator is more important than the cost of this safety relay. All right. And not only that, for those OEM machine builder, if they integrate this feature, they can even upgrade the safety level of their machine. Okay, it's a good selling point for them. All right. So these are some of the targeted applications that we identified. Okay. So through our sales achievement in our safety product, we noticed that most of the machines and system, for example, packaging machine, food machine, industrial robot, machine tools, semicon manufacturing equipment. So all these machines and robots, they belongs to a lower risk equipment. Okay. So between performance level D and performance level D, the required performance level is between B and D. Okay, but definitely we know that eventually the required performance level still need to go through a proper risk assessment. But after the risk assessment, normally this will be the range of the required performance level. Okay, so this is the low risk level machines where our category 2 of safety relay is suitable in. So if let's say you have some existing customer who are making these machines or this kind of solution, probably you might approach them to check with them whether they are using category 4 of safety relay. If yes, then probably we can introduce this for them to lower down their costs. If let's say they're not using any safety relay, so it's a good time for them to integrate this in to further protect the operator and upgrade the safety level of the machine. Okay, all right. So this comes to the end of this webinar. So in case you guys got any question, please feel free to drop the question to my email or these 2 email addresses. So I will see you guys in the next session, which will be next Wednesday. Yeah? We have rescheduled to next Wednesday from this Friday. Okay, I will see you guys next Wednesday, which will mainly talk about how to determine the safety performance level required by your machine. Okay, so some calculation will involve during that session. Okay, so I will see you guys during this session. Thank you very much. Thank you for your attention. Goodbye.